And good evening everyone who is watching the stream of AD arrives on air, and welcome to my what's clicking? It's like the music clicking. Yeah, it sounds like the music has some clicking in it. So good evening everyone who is watching the stream of AD arrives on air. No, it is clicking. Not clicking anymore. So good evening everyone, the third time who is watching the stream of AD arrives on air, and I was actually going to do the full build today, but again I ended up being late. I spent all day outside, the whole day outside, running errands pretty much on my feet. Ended up walking a lot. Ended up getting home pretty late, ended up not getting enough sleep, so I decided, and since I forgot about one thing, I decided let's work on that one thing today, just because, where is it? Just because it kind of needs to be worked on. So I have tested everything. The new hardware that I'm going to install, motherboard, CPU, memory, I've tested it to, I don't know, to the extent I've never tested any of computers. I think definitely I've never tested components for me in that hardcore way. So I've tested some other systems pretty hardcore way, but that wasn't for me. So And one thing that I haven't tested, I haven't even installed yet, I haven't tried yet, it's the custom bracket for the CPU mount. So let's work on this one. So can you see it good enough? Maybe a little bit darker would be better. So just to make it a little bit more contrasty. So good evening, Crimson Zamboni, you're the first one. So what is going on? What are we even talking about? What's this thing? So let's get our motherboard and let's start talking, showing examples at the same time. So that's the motherboard with the CPU installed already. So here we have oh, now the picture is a little bit darker. So let's open apertures a little bit. So this is the motherboard based around the latest Intel socket, LGA 1700, so 1700 socket. It's different from all previous consumer sockets because it is elongated. As you can see, it is not not a perfect square. It's kind of you can see it's a rectangular. It has rectangular shape. So, and there has been a problem. Even I can call it a scandal. People figured out that this, well, retention bracket, locking mechanism, Intel calls it actually independent loading mechanism, this bracket here that holds the CPU in place, that it, because it's pretty much copied from square CPUs, it does not lock these elongated CPUs properly. So Intel tried to save money. They already have a perfect socket for big CPUs, and let me show it to you. The perfect socket for big CPUs, the perfect mounting mechanism. It is this. So this is something a little bit different. So as you can see, it's way larger. It has two actually levers. It's pretty big bracket. So, and it's pretty much a server thing. But if you need to mount a big CPU, if you need to even the pressure out of the mounting bracket, yeah, you got to use something like that. No, Intel decided to copy its consumer basic ILM, independent loading mechanism, and got problems. So this bracket does something to the CPU leads, or it's called integrated head spreader. So the cap of the CPU does something to the CPUs, and it bows them a little bit. So especially under the pressure of the cooler, which is strange, but it's been confirmed many times on many YouTube channels and other researchers, let's put it that way. So the fact is that it is happening, and this mounting bracket, this independent loading mechanism ILM, is not spreading the tension, the pressure evenly enough, and that's why well, independent manufacturers came up with custom CPU holding brackets, and this is actually the second custom one that entered the market. The first one was a pretty expensive bracket from Roman Hartnung, aka Der Bauer. It's Thermal Grizzly company, and it was Thermal Grizzly bracket. So pretty expensive because made in Germany with like German manufacturing practices, very low tolerances, and otherwise just in all relations a perfect product, almost perfect. So this one is from AliExpress. The company is called Thermal Right, so it's not completely no name. It's not complete no name. So that's the box. It has even some sort of authenticity code. So to avoid buying fake stuff. But again, I bought it on Ali, and the price of this one is like $4 maybe. So basically what it does, there has been already many reports on YouTube, on forums and whatnot, that using one of the custom brackets, this one from Ali or the one from Der Bauer, it actually decreases temperatures of the CPU. Sometimes, well, decreases, drops down all the way to like up to 10 degrees lower. So in like max under max load and under max load, and at temperature spikes. So that's it. I haven't done any tests on this CPU with this standard bracket. I haven't recorded any thermal values, any temperatures. I've done a ton of tests, but just I wasn't looking at thermals. They were okay, and that was it. So so I don't know when we install this one if it's going to be like a big improvement or not. But again, there has been reports. If this bracket doesn't work for you, or if you just install it not in a proper way, over tighten the screws, for example, so you will end up with your thermals actually increasing compared to this. So if this thing doesn't work, we will know. If this works, we will know as well. Fisher, good evening, welcome. 9th gen, my current CPU, well, technically my current CPU, it's 7900X, Intel 7900X, so it's like 7th gen, I think. It's HTDT, it's not consumer, it's like enthusiast / workstation. So, but a good CPU, 10-core CPU, but again, this CPU 13700K, i7 13700K is twice as fast as my 7900X in different Cinebench tests. So okay, so first of all, to mount this thing, to use this, we need to remove the old retention bracket slash independent loading mechanism slash locking mechanism. So since the bloody thing is spring loaded, never unscrew it while the lever is locked down here. So first, free it up. You can open it if you want, you can close it, doesn't matter. Just free it. unlock it, and then start using a small Torx, how is it called, screwdriver wrench, to undo the screws here. They are not tight, you can feel it. I'm just like turning it a little bit, and they are not tight at all. And that's how they are supposed to be, not tight. So people make a mistake when installing the new retention bracket, the new, well, CPU retention bracket, CPU locking bracket. They over tighten the screws. No, absolutely not. You don't need this. This, okay, and add just a second.
It helps us work and fill radio space with quality and wonderful lounge music. Any amount of money will help us continue broadcasting. If you want to join us in supporting your favorite radio station, go to the official website loungefm.com.ua and click on the banner to find out how you can help.
So this is the first time actually in my life I'm disassembling the CPU mounting mechanism. So it's actually, Intel ILM consists of two parts, the lower part and the upper part. So this how it looks without the mounting mechanism. Of course, don't throw it away. If you need to RMA your motherboard, you will need this. You will have to install this back. Technically, since unmounting this old mechanism and installing a new one and then going back, since it all doesn't leave any traces, technically it shouldn't void your warranty. But if somebody learns that you did this, that will be, yeah, that will be voided for sure immediately. So I'm keeping the CPU in the socket just to protect the socket itself. There's like that grid array down there, and it's extremely easy to damage. So those thousands of pins, actually the socket is called LGA1700 because there's 1700 pins down there and the socket. Okay, so we have the screws, we have the frame. It actually looks pretty cool. I should have bought the black one, but the gray one looks good too. The thing is that they have actually bright red ones, bright blue ones. The colors are amazing, and but it's not going to be visible whatsoever, like not a single part of it, because there will be like a gigantic cooler here. So, and now let's start walking in the screws. So the thing is, we got to really be afraid of cross-threading it, because well, this is going to be a problem. So, and over tightening them. So this is the AliExpress one, thermal rights one. You just got well, you don't have a torque wrench here, torque screwdriver. You just got to believe your fingers, got to rely on your fingers, on your feel of resistance. The Bauer's one, they have like a pretty sophisticated way of actually tightening it down. So okay, so first of all, let's walk screws a little bit back. Can you hear it? When I'm walking it back, there's a click, and the click when it jumps into the thread. So that's a way to avoid cross-threading. So a little bit down, then do the same with another one. First a little bit back, then a little bit forward. Doing it in a diagonal manner. So a little bit back, click, a little bit forward. And a little bit forward. So, and now we got to start walking down them slightly, carefully, trying. So the idea is to do it in a crisscross manner, diagonal manner, and just beat by beat. People recommend walking the screws down in like 90 degrees increments. So like this, then this, then this, then this. Of course, this is like a little bit of an overkill because currently it's like free, but 1, 2, 3, 4, and then 1. Oops, so there is resistance, and I even can see, I don't know if you can see it, I can see the whole bracket moving when I encounter that resistance. So got to be careful to actually not skew it. So we just go walk it down a little bit to that resistance wall where it starts, but we are not going in there yet. Just a little bit. Then the same here, the same here, and the same here. So technically it is done, because the grid array, the pins of the grid array, they are springs too. So, and currently it is being just under some how to say it right, under some force produced by just the pin array under the CPU. So, but I'm going to do it a little bit more, just a little bit more, just a little bit more, and that's it. So I'm just going to check. Yeah, I'm trying to recreate the level of pressure that the level of tightening that was actually on this original socket. You can see it here on the small window. So the original bracket wasn't really tightened down by screws at all. It was really easy to unscrew it, just like so. I'm just doing it pretty much in the same way. So here we go, as tight and as even as it, well, as tight as it should be. And because we really didn't let it to be over tightened in one corner and loosened in another, it should be really even, really flat. And it's not moving, and this is enough. Technically this is enough because, well, it holds the CPU in place, and it helps to even pressure out from the cooler, from the cooler's radiator, from the cooler's heatsink. But it doesn't need to be like extremely tight, because itself, this frame, is not really experiencing the loads that would try to pull it off the motherboard. So here we go, we have it mounted. Let's get rid of this, and now let's try to run it. So we need the cooler, of course. We will need the brackets. So let's mount everything back here. So kind of like this. Can I mount it vertically? Actually, maybe it is possible. Maybe it's possible to mount this cooler vertically. So as you can see, the socket itself, the processor itself, the CPU is rectangular, but the mounting holes, they are in a square. And I'm a big fan of actually allowing the air to flow according to the laws of physics, from the lower parts of the case to upper parts of the case, and only helping it on the way. So let's see if actually it's going to work. I'm kind of curious if it's even possible. Let's try to do it. Maybe it's not recommended by the manufacturer, but I want to try it. My previous cooler on 1700X, different cooler, different motherboard, different socket, was mounted vertically with pretty good results, I'd say. So let's see. No. Unfortunately, this is not going to work. The brackets are too close to each other. Wait a second. Maybe we just gotta do it this way. I don't remember the way it's supposed to be. Okay, what if we put them like that? Okay, let's try to tighten it down to see what's possible and what's not. I'm curious. So if something goes wrong, we always can remount it. So we don't need this anymore. That's just now standard stuff. So these brackets, they move. Well, the brackets, well, they are technically brackets, and they're not supposed to, really. Okay. Yeah. This way. So this is not the final CPU mount. I'm going to well, the thing is that we are doing is just for testing. Let's actually populate memory, because it's easier to do now. Populate all the memory slots. It's easier to do now than later. So yeah, the memory that I've tested. Learned an interesting thing. Don't even expect 4 DIMMs of memory to work on XMP1 profile on a consumer board. That would be just too high for 4 DIMMs. Oh boy, I'm already out of battery in my wireless earbuds. What's going on? Here we go. satisfying. Click. So this is going to be 64 gigs of RAM. Probably was a mistake. Should have bought a motherboard with actually DDR5 and bought maybe 32 gigs but DDR5 memory. But I bought the DDR4 motherboard because I initially wasn't going to buy any memory at all. So I still have the memory from the previous motherboard. Okay, so we have the memory installed. Just give me a second to figure out the headphone situation. Just a second. Okay, cannot hear you anymore. Cannot hear music anymore. So they got discharged that fast because I actually been using them before the stream, so there's nothing special about its charge. Just a second. Yep, charging now. Let's take another pair of earbuds. And hope they connect to the Bluetooth transmitter. Super. They have many cheaper Bluetooth earbuds. When they connect when I power them off. Hey, come on. Here we go. Have the sound back. Cool. So, okay. Let's see if we can mount this cooler vertically. So not only we experimenting with the new CPU bracket today, CPU retention bracket, but we are experimenting with we're experimenting with mounting the cooler in a different way. You cannot see it probably. Let me just open the aperture a little bit. Yeah, the clearance there, it's like millimeters. But if it clears it, that's going to be great. Okay, let's see if it clears the memory. It makes it actually impossible, completely impossible to remove one of the sticks, but it clears it. Normal horizontal mount with this memory configuration results in a need to move one of the fans a little bit up, creating this way like less efficient airflow. So, but let's see if we can like tighten it down. I know there's no thermal paste in there. I am just checking. So, walking down these screws. Yep. Cut the thread properly.
Lounge FM, chill out. The best relaxing music.
Okay. I know there's no thermal paste in there. Here we go. Here we go. Okay. Just taking a look at it. It is. I wish I could show you. The heat pipe is almost touching the last or the first dim in the slot, almost, but there is like a hair thin gap between it, so wouldn't be a big problem anyway. So technically looks okay-ish. I'm not seeing any clearance issues, any other, everything else is not even close, so feels tight, feels okay. The video card, haha, let's take a look at this. So the video card with so I still have here my GTX 1080, not RTX 3060. So because well, 3060 is still in my current temporary rig. So let's see if I can clear that. Oops. Okay. Not optimal. Not optimal. The airflow here is obturated by the video card. I don't know if you can see it. Wow, it's so dark. So should be sharp enough by the look of it. So so you can see the gap here between the video card and the cooler. It is really small. That's why I've been trying to first measure it, because when I put a fan in here like this, what happens? There's just no air for the fan to intake. It's more than half of it, like 60% of it, it's just covered by the video card. So it's cool. vertical mount is possible, but if you don't have a big video card. So, gonna get you, good evening, welcome. Yeah, you're absolutely right. That's why I've been trying this stuff, so to figure it out like on the real hardware, not in theory. But good to see that this cooler can be 100% mounted vertically. So, ow. Now let's remove it. So, and now let's remount the cooler the right way. It has this cooler, it has two fans, one intake here and one push-pull in the middle. So, and technically you can put another one on the top. So, but on the top, on this side, it's not the top, it's going to be the left side. So let's unscrew it, redo the cooler mounting brackets properly. Just oh, come on, there was a click even. Here we go. So this has been removed. Now the brackets. Let me actually return that camera angle. Ooh. Almost dropped the cooler, the heatsink on the ground. Manual focus, just like good old days. Here we go. Pretty bright for the socket and for the CPU, and actually okay-ish for the black motherboard. Okay. Now it's time to mount this stuff back. So this is the way to mount it if you need horizontal mount, just like a normal person. So this is a deep cool Gammax series AG620BK, but I changed the RGB fans for a different model, the model that actually supplied with not RGB version of this cooler. And these fans, even though they look pretty much almost the same, they are not RGB, they actually have better performance Well, I mean, technically you can use any fans there, but so I bought the RGB version, and I bought non-RGB fans to replace the RGB fans, because I just couldn't find the non-RGB version, the one that performs a little bit better. Here we go. Now let's mount this again. Yeah, looks perfect. Let me try to thread it a little bit. This one's not catching the thread at all. Here we go, caught it. Okay, let me take a look if everything is even, because the way it works with these CPUs and with these coolers, it's that every even tiny fraction of a millimeter counts. So Gamers Nexus, Steve from Gamers Nexus, they made a video about the problems with these CPU mounting, Intel CPU mounting system, Intel ILM, and they used a special way of like something like pressure sensitive chemicals, paper, something, to actually get a print of pressure applied by a cooler to the surface of the CPU's IHS lid, the lid. So, and it's visible. It's really easy to see from those prints that even if you cannot really see visually anything, any problem, for example, on a standard CPU mounting bracket Intel ILM, it's possible to get like up to almost like 1/3, maybe closer to even half of the CPU not having the lid of the CPU not having a proper pressure applied, which is insane. So that's why I'm kinda tightening everything down really carefully, really keep checking everything here. So I have a special thermal compound, thermal paste for this build, Thermal Grizzlies Crying Out Extreme. So Thermal Grizzlies Crying Out Extreme, but I have very little left of it, only for one application, and I'm not going to use it right now because just a little bit. I used the majority for repasting of the new 3060 that I got from AliExpress. People in comments there in reviews actually mentioned that the card works better if you repaste it. The thermals go down. So I repasted the video card, a little bit left, enough for the CPU. This is probably the best thermal compound on the market if you just compare the numbers of thermal conductivity. They unfortunately are not printed here on the back anywhere on the packaging, but I tried to find something else, some other thermal compound with higher thermal conductivity numbers, and I couldn't. The only thermal compound that has higher conductivity numbers than this is the liquid metal. But liquid metal, it's like you got to be ready for problems, and liquid metal turns out it degrades over time. This thing, first of all, it's stable as hell. Second, it's crying out, so it's supposed to work properly under extremely low temperatures, but it is absolutely okay under normal temperatures, because well, I mean, if you overclock the CPU under liquid nitrogen or anything like that, the CPU still gets hot. The thermopaste still gets hot there, even under liquid nitrogen, so it still can get pretty hot. And the paste, of course, the compound, of course, should be able to handle that perfectly. This one handles extremely low temperatures and normal high temperatures of a working CPU equally good. That's it. But very little of it left. There's like a small syringe, 2 grams, I think, and that's why I'm going to use MX5. It's probably the next best thing. So to this, it's very good compound, but this CPU, it's like it's crazy how hot they get these days. When I got my 7900X, the previous CPU, 10 core HDT CPU on X299 platform, I was amazed that it was how hot it was. It was like unbelievably hot. So this one is even hotter. I don't know where it goes, but yeah, it goes to like towards sun temperatures, I think. So because this CPU is larger than all the previous consumer Intel CPUs, I'm not talking about HDT, I'm not talking about Xeons, I'm going to use a small, how's it called, a small tool to spread it out on the CPU to try to create an even layer. People say it might be not necessary, but that experience comes from the normal smaller CPUs. This one, it's not a monster, it's not like a Xeon monster, but it's getting there. I'm covering the socket in it, doesn't matter. Not the socket, the new bracket. Okay, I think we got to add a little bit on that corner. There's a little bit on the tool here, but I don't like this one. It's pretty thick, like it's not really that liquid. I'd prefer it to be a little bit more flowy. But it's pretty sticky, It's not really that flowy at all. Okay. Something like this. So it used to be 100% not needed to do this, but these days with these CPUs, yeah. Plus, well, people with, for example, Xeons, people with, for example, Threadrippers, that's pretty much not a thing anymore, but still. So okay, let's install the fan and run the system. That's the idea. I want to see if we can see the thermal difference here. Here we go. So slowly walking them down carefully, because the whole thing is actually using only 2 screws to be held down. So only two big screws, yeah, but only 2 big screws apply pressure to the socket, which is, yeah, not optimal. Just the design of the socket is flawed. It should have been something close to 2011-3 square ILM. Yeah, I think something to the socket used for X99, X299 platform. So this one actually is walking way down there. Is it even even at this point? Well, okay, that's not good, not even at all. Anyway, I will remount it. If it's good, if it's bad, I will remount it anyway, using the proper thermal paste. Using the proper Cryonaut thermal paste. So, okay, it's down there, this time for good. As you can see, there's no way, unfortunately, to see that beautiful retention bracket for the CPU. So maybe this angle. It's so freaking dark. So let's make it a little bit wider. Let me get the focus right. Looks good. Then let's move it like this. So the memory slots are populated. Time to install the fence. So again, just again another testing installation. So there was a fence splitter in the box. Let me actually find the box. The box is gigantic for this cooler. Cannot even fit it on the frame. Willie, good evening, welcome. So where is the splitter? It of course comes with its own bag of thermal compound, but I don't need it. There is a hub. Yeah, there's a fan hub in the. Ah no, it's not from probably from the cooler. The fan hub's probably from the box of 3 fans. So these are not the kit fans for this cooler. These are FK120. That's the model on them. Slightly better performing ones. So the splitters here. Want to use the splitter this time. So let me move it around a little bit to make it easier to install. Just like that. So one goes here. Going to move it. So this is, as you can see, it's higher now. It sits higher now than the radiator. So the part of the radiator is not going to get the airflow, and some of the airflow is going to be wasted. But what can I do? The memory is down here. It gets in the way. So, and I'm going to clear the memory. I'm going to add like a couple millimeters on top of it. I don't want the fan to be touching the memory sticks. So now this one the same way, but this one goes all the way in. Okay. The cooler is humongous. It's like most part of the build now of this motherboard. So okay, the splitter is pretty useful because you can just run these two coolers, these two fans on one CPU, header, which is probably the best way to do it. Controlling them separately, that's not really the best idea. Of course, there's nothing really bad in that, but controlling them separately, why would you need to do that if you can just run them on one header, on one CPU fan port, and they don't really draw that much current, nearly that much current to overload it. Okay, this is done. Now we need power, so I'm going to use the power supplies for the build. Soulless Yeti, good evening. Soulless Yeti. Sorry, I didn't see your name at first. I wasn't sure if I read it properly. Evening, welcome. It's going, we're getting by. Well, assembling even a 1700 based new rig. So but yeah, everything is going. So this is the power supply that's from my main rig, not the new one, but since I'm upgrading, I'm not building completely new, not building a completely new PC. So Corsair RM850, enough for this, of course, and enough for many other things, I would say. So first of all, we need to plug it in here. Just give me a sec. Like that. Fully modular. So you even can remove the motherboard power from it, which is technically never needed, but so then we need CPU power, 2 of them, because this motherboard takes 2 8-pin connections. Cordless drill packs. This drill actually still works absolutely amazing. I pretty much saved it. I'm so happy I did it. It's big, that drill, it's big, yeah. It's not like a screwdriver, but I'm so glad I fixed it. So I've done quite some tinkering, DIY tinkering since then. So not only that one. So do we have enough length? We might not have enough length here. So this we can route like this. Okay, and this we can route from behind. Is there focus? Tell me if it's unfocused. Looks a little bit like it's out of focus now. Trying to catch those ones as sharp as possible. Okay. No autofocus. Good old days of focusing it manually. So 1 CPU power goes in here. So my previous CPU 7900X was pretty power hungry, but it used one 8-pin slot and one 4-pin slot, 4-pin connector. This one uses two 8-pin connectors. So you can see what's going on here. Here we go. We have the power. Now the video card and its power. Just a second. So type 4 goes in there, and this goes into the card. So going to use right now GTX 1080, my old one, that I'm not going to get rid of, because so I have 3060, but this one stays as a spare one, and I'm going to freaking end up having a spare PC. Well, I mean, it's already happening. Spare PC. Pretty much already happening. So the spare PC, I'm streaming already using the spare PC. So this stream is being sent from another PC. The one that I bought, well, the CPU, the motherboard for it, I bought on AliExpress. The Chinese Xeon stuff. No, if you all you need is just to play DZ and stream it, yeah, 100% enough. But I want to play something like Star Citizen, and that one would be a little bit not enough for that. Well, I mean, with Star Citizen, the more you have, the better. Okay, the power's here. The video card's there. Well, technically this has an integrated video card. I keep forgetting about it. I spent so long on X299 platforms, CPUs on an X99 platform, CPUs of which they don't have any integrated video cards. So that I keep forgetting that we have everything we need here and just in the CPU. Now I have a hard drive with Windows on it already for testing purposes, so just an SSD. And we will need a SATA cable. I have already learned where SATA 1, SATA 2, SATA 3, SATA 4 here on this motherboard. I found silk screened well, info about it on the board. So it's just in order to have all the drives connected in the order of their the way they appear for me in Windows. So NVMe of course is going to be the C drive, but then SATA 1 is going to be the D drive, and SATA 2 is going to be the well, D, C, D, E drive. So here we go. Now we need to get controls, a small keyboard, and we need to get video output for you and for me to be able to see anything. So I don't have a monitor here, as you can see, so I'm going to use a capture card, this one. I'm going to pretty much look at this the screen of this computer through OBS the same way as you. So just connecting it. Video output, HDMI, videos here. Now we need a keyboard and we need a way to turn it on and to see the LED activity, and I have special wires for that, just to make it a little bit easy in case we will need to restart it a lot. Tinkle Toast Twitch, good evening, welcome. Good evening, welcome. well, I mean, no, it's pretty standard looking motherboard. It's just a gigantic cooler. So, and the new retention bracket is already under that cooler. You can take a look at it in the beginning of the stream. So, the old retention bracket Intel ILM, yeah, here it is. Actually, I didn't know until recently that this consisted of just two different independent pieces. I thought it was just one frame. Okay, where did I... Hey, my wires. So once for turning it on properly. So just a sec. Well, this is 13700. The bloody thing gets pretty hot. Not as hot as 13900. So okay, there is silk here. Silk screen, power LED, power switch. Power switch. Why does it still have polarity, huh? And we need hard drive LED. That's going to be this one. Just to have it easier for us to turn it on and to monitor its activity. So the yellow one here is the plus. So this is just for testing purposes. We installed a new bracket, a new CPU retention mechanism, CPU lock, and we are testing if this just starts. So just give me a second. Maybe a little bit like this. Yeah. So a keyboard and mouse. Keyboard and mouse. And for this, I'm going to use this amazing micro keyboard with a touchpad. So costs like $5 on $5 on Ali. Amazing if you have a it works as amazing remote if you have a like HTPC that doesn't not even running any like software for HTPC. It's just pretty much standard Windows. I use it as a remote for my HTPC. It's a full-fledged keyboard, just wireless and in form of just a slightly large controller. If you need to type a couple letters, it's here. The mouse is here, and all the basic stuff like cursor keys and stuff, it's all here. And it has RGB lighting, so works in the dark. What I don't like about this motherboard, because the CPU is almost the highest tier, like next to the top, not the top but next one. So but the motherboard is basic. I bought a basic motherboard, and I'm actually feeling myself a little bit limited with this motherboard. Normally it does not matter, does not really change the speed of your CPU, does not really change, I don't know, speed of your memory. So, but what matters, it's like overclocking capabilities that I don't care about, not going to overclock this. To overclock this one, I'll need water cooler, 100%. I mean, water cooling system, something, at least an AIO. So I'm not going to go that way again, at least not for now. So no overclocking, but more expensive motherboards, premium and whatnot, they simply have more USB, and I need a ton of USB, and I'm not sure this motherboard has enough USBs for me. So maybe I will end up buying a USB hub, maybe like it. By the look of it, it has Thunderbolt, so that can be pretty much split in as many USBs as I want. But again, to have it just on the back panel of the motherboard, it's like the best way to do it. So okay, we need power, of course. We need freaking power. Just give me a second here. We need a power cord. So, as I said, I did not disassemble the video card to clean it. I did not disassemble the power supply to clean it. So I'm going to reuse both. I used the remnants of my compressed air, and the power supply was almost clean. This card, I might need a little bit more compressed air to clean it, so I ordered another two cans of it. So, but yeah, because disassembling this one is a little bit too hard, and it will involve removing the radiators, the heat sinks that I don't like. I just wanted to remove the shroud, but there's no way to do that without removing the heat sinks. And the power supply unit, disassemblable of course, but since it's a power supply unit that has a fan stop function, so without load or under like relatively low loads, it doesn't run the fan, it doesn't get the airflow, it doesn't get the dust, so it's not really dusty. Little keyboard talks to the PC. No, it's not Bluetooth, it has its own receiver. I think it's like the same standard that other wireless keyboards and mice use. It's not Bluetooth, it's something theirs, but it's pretty much enough for, well, typing in a couple letters. Okay, let me fix the focus here like this. We have been a little bit not focused. So everything is ready. I don't have in this monitor, because it's basic, this motherboard because it's basic, it doesn't have the error code digital panel. So I'm really used to that. So it has just lights, CPU, memory, boot, and something else somewhere here. Yeah, here we'll be able to see them. So let's power it on and see if it works. Here we go. No image. That's supposed to be the image. No video output so far because it's training the memory right now, and technically it will ask us to, oh, here we go. Oh boy, that's a problem with MCI biases. That's how they get captured. So, I mean, that's capture card problem and the low resolution monitors problem. Looks okay on 1080p, but just give me a second here. Nah, it's not really changing. So, but we can try to press F10 and enter and reboot. So yeah, MSI has a problem where if you connect a small monitor, old monitor, or if you connect a capture device, the bias might not get captured properly. So boot indicator, white one, booting. Here we go. Are we? Yep, we are booting in Windows. Already amazing. That's going to take time because, yeah, getting devices ready. Windows will try to install at least some drivers or some just standard drivers. Oh, here we go. 1080p. Everything looks amazing here. So let's give me full preview. Let's remove everything from the screen. And these two. The counter we don't need. So I'm seeing pretty much the same as you, but I'm using this keyboard. So is it even working? Yep, here we go. So the image might be a little bit how to say it right, jittery, because this video card, this capture card, it's the best for capturing different resolutions. As you can see, it even tried to capture the bias. So if it were a normal bias, like the old one, text mode, yeah, it would have been 100% okay. So this machine running, this here machine, this is its screen, so being captured. So what's going on with our thermals? Let's take a look. So everything here is prepared for testing. So of course no commercial use because we are just having fun here. So this is sensors. So we don't have memory. Oh, we don't have memory configured properly. Well, I mean, what's not proper there, it's running currently not on any XMP profiles. It's running on default 2400, I think, mega transfers per second. But that's not a problem. Low frequency, it's like not a problem. The problem is that these D modules here, these ones that you cannot see over there, 4 of them, they actually need 1.35 volts of power, and by default the motherboard sends 1.2 volts of power, volts of voltage. So it automatically switches to 1.35 if you activate XMP profile 1 or 2. And XMP profiles on the memory, if you don't know, it's just like officially acknowledged, no, officially allowed, no, officially proposed memory overclock. Basically, that's pretty much fixed in the memory information module. Every DIMM stick has like this small chip with memory info there. So, and pretty much it's like the easiest way to make the memory work at its highest, safest, even safest speed. So always activate XMP profiles, or they call DOCP. They call it a little bit differently on AMD. XMP it's on Intel. AMD DOCP, I think. No, something like that. I don't remember. Don't quote me on that. So always activate them if you can. So, but on consumer motherboards, if you have all slots populated, you might not be able to use XMP Profile 1 because it's still technically an overclock, an official overclock, but still an overclock. So there is that. Oh, what did I do? Remote center, I don't need that. I just wanted to. How do I scroll on this keyboard? Can I even scroll on this keyboard? So currently our CPU is just resting, as you can see. Temperatures, current temperatures of P cores in E cores. The CPU has different types of cores. P cores is like power cores, I think that's what P means, and E cores it's like efficient cores. So, but doesn't mean they are not powerful. Every efficient core, it's like one core of 7700K. Specified overclock, yeah, let's put it that way. So every efficient core on the CPU is like one. Remember 7700K, pretty capable CPU, only 4 cores though. So every E core is just one core, it's like one core of that. So on P cores they are even faster. So okay, the memory is not currently in the right mode because I cannot really use BIOS with this capture device, because MSI has like some problems with their BIOS interface when it comes to non-standard resolutions, and it cannot, when it boots, the BIOS cannot, the UEFI BIOS cannot detect the proper screen resolution because there's no screen, there's a capture card. So, and it fails to just draw the interface properly. So okay, now we need a test, and for that I'm going to screw it really seriously. No, not this, sorry. I'm using this touchpad. It's small. It's okay to just control maybe a movie, but this, let's experiment stable diffusion experiments here. So it would be easier to use just arrow keys, and I'm trying to use them. So kills LinX. LinX, it's a GUI, graphic user interface for a LinPack. Yeah, we don't need Hairy Donut. We don't need it because we need to hit the CPU. And this is how you hit the CPU. So the test might actually kill the system because of the memory, not because of the CPU. But we have thermals on the screen, that's the right columns, and we have the test here. So problem size 36, and see how much memory we have available to us. 31 gigabyte of memory. So problem size, we can increase it to just use all the memory. That's actually another way to test the memory. It's not as good as, of course, memtest, but if there's a memory problem, the test won't be able to finish. So 6,000, that's not enough. So we need like 85,000 or something. Let's try to just type it in manually. 82,000. No, not enough. 90,000. Close, really close. Let's go 1,000 back and do it 89,000. Yeah, more like that. So this screws your CPU like for good. This is like hairy donut for the CPUs. And start. So again, this Windows 10 is not able to properly work with 12th and 13th generation of Intel CPUs, just because of the CPUs having different cores. Windows 10 cannot see the difference between them, and thus it cannot use them actually properly. So but in this test it will just load them all equally, so it wouldn't matter. So right now I think it's preloading the data for the test. It's not running the test itself. I mean, it's only getting ready. As you can see, the thermals are still very tame. The highest core is like, was it 68 for a second? I don't like if there's a hotspot. 69, 59. Interesting. Some of the P cores. Oh, and now it is hitting it. 80 on some of the P cores. And on the package we have 80. But this is a very serious load.
The best relaxing music.
So, and the coolers. Oh yeah, we just need to adjust cooler profiles. We really need to adjust cooler profiles. Because the fans are not going nearly fast enough. So the radiator seemed to be just a little bit warm, but this is not nearly fast enough. So it can give us way more cooling capacity if we just readjust the curves. It's very silent though. So the CPU is like 80 degrees, and this is the load. I won't be able to produce, for example, playing Star Citizen and streaming it at the same time. I won't be able to produce even doing that. I won't be able to produce such load. So, but now I really want to take a look at my previous stream where I pretty much tried to run the same test. And my previous testing stream is still saved on Twitch. It's without number. So to take a look at thermals there. So do we have any hotspots right now? Doesn't look like we have any hotspots. Well, efficient power cores, yeah, some of them are 85. Was 85 for a second, but that's kind of like, that's kind of okay. I mean, you know what? So we are currently running from CPU cooler header, but if we replug the CPU cooler, if we replug the CPU cooler to water pump header, we might be able just to force them to start spinning like at full speed at 12 volts, because currently, yeah, I barely can hear them. It's very quiet cooler, and it's not particularly warm, it's not particularly hot. So getting 80 in this test under this cooler. So this is not a water cooler. And getting these temperatures in lean pack. What's our distance actually to T max? Let me take a look. Oops, that's too fast. Scrolling. I'm not seeing the T-max here. So the CPU is not throttling. No power limit exceeded. So we are not close to T-max. Is there a column with T-max? CPU package power. The CPU is currently using 200 watts. Actually, maybe there is a point in undervolting it a little bit. So that's value is reported by the motherboard. Core 3.5. I heard that some of the motherboards, they sent a little bit too aggressive voltages to the CPU by default, so that it's not necessary to go that high. So stable 81, 83, 84 on the package, so doesn't go higher than 85. And this is a killer test. This is a scientific calculations, and we're actually not just running some equations. It took all, we created a problem that took all our memory, so it is an incredible CPU load. And it is working. I like it. So I'm not sure if there is a big change compared to the standard CPU mounting bracket, because I didn't do this as a comparison of different brackets, but at least we have it working stable. I don't see any obvious hotspots. Yeah, P cores are running hotter than E cores, but that's normal. So there's like cores around P core 3 tend to run a little bit hotter than everything else. But again, that's not really critical at all. Plus, we still have one joker in our sleeve. Thermal Grizzly crying out, thermal paste. The one with even better thermal parameters, so thermal conductivity parameters. These coolers are not even like sweating. The fans, they are not even sweating. They are far away from full speed, like really far away. So I'd replug them into the water pump header which normally gives you like 12 volts without any voltage lowering, voltage regulation. So it's just 12 volts and that's it. But I'm afraid to do it on the fly while the system is loaded. Okay. While this is happening, let me actually find my previous. So the problem is that I don't have access currently to my archive of streams, because the drive with my archive of streams, it's just on another desk there, just on the desk, not connected to anything. So I have a little bit of an archive, my own. The problem is that, well, it's archive not available. My own. Shut up. So let's take a look at the testing stream. So, ooh, okay. I already can see the difference. Let me show it to you. So I hit, how do I capture this? So here we go. I hit, this is from my previous stream. See the numbers here? But I hit it a little bit harder, so it was DZ running in the background, it was superposition running in the foreground, and it was lean pack calculating something, and it was OBS working. Look at the temperatures though. So we pretty much were way over 90 here on that's P course, that's the power course. So, and we definitely were throttling. So the CPU was skipping cycles, the CPU was dropping basically its frequencies because of thermal overload. So yeah, so I'm not going to replicate exactly these conditions like DZ in the background, Unigine in the foreground, OBS capturing and encoding, because one lean pack actually gives you 100% load. Lean pack, Linux gives you like 100% load. So the rest was just trying to get some CPU power from lean pack. So, and our thermals here, well, you can see actually P-Core 3 and P-Core 4, they seem to be hotspots no matter what, so maybe they're just turboing harder. And this is what's going on currently on our current CPU. Just give me a second, I'm not seeing it. So we had 96 for a second on the core and 96 on P-Core 7, but in general on average yeah, we haven't been well, throttling a little bit. We have been throttling a little bit. So, but we can fight that. First, better thermal paste. Second, cooler speed curves. adjusting fan speed curves for the cooler. The thing is that the difference between this and no, not this. The difference between this and what it used to be is obvious. So look at this. Like, it's all in red. Pretty much every core maxed out on temperature at some point. So, and we're not running graphical benchmarks and DZ, but lean pack is enough. Lean pack is just enough. So I think this is a good result for air cooler, because I've seen people getting pretty much the same temperatures with AIO water coolers. So yeah, and it is not even loud. So there is some headroom for improvement just by adjusting the fan curves and just by applying better thermal compound. But overall, I really like what's going on. So I will of course remove the radiator, remove the cooler to repaste it, and I'll try to take a look at the pattern of pressure. Sometimes you can see the spread of the thermal compound. You can actually find a picture in my Twitter where from that picture, by the just pattern of thermal paste spread on the lid of the CPU, I think it was possible to make the conclusion that one side of the CPU wasn't really getting proper pressure, and that kind of corresponds to the findings that I saw literally yesterday. I watched that video, saw in Gamer Nexus channel. So Steve there, using a special paper sensitive to pressure, got patterns of applied pressure, and there was a couple patterns in the series of presented that demonstrated pretty much the same result. One side of the CPU, literally like a line around 1/3, not getting proper pressure, not getting proper thermal paste spread, not getting stuff like not getting pretty much proper thermal interfacing. Well, you got me. So I forgot the right word. So right now it is working, and it's going to work like that, but I don't think we need it. So we have a little bit of red there. For a second, a couple cores went into one core actually, P core 7 peaked to 97 degrees, and that was it. So that's, you can deal with it. So I guess the only thing that we have left is to just disassemble it. And actually, yeah, maybe let's disassemble it and let's take a look live at the pattern of thermal paste spread on the CPU lid. So give me a second. Let's turn this off. So here we go. I will have to repaste it anyway, so why not now? Let's just disassemble everything. First, let's cut the power completely. So, of course, there's like people who would always talk about bottlenecks in the system, and of course, using this CPU with a 3060, it would be like a gaming bottleneck. But it's for only for people who just game. But if people like me, they game and then encode it in on the CPU in H.264 codec, well, the stream, H.264 stream, and send it somewhere and do it like in a couple different directions. So yeah, the balance actually shifts towards CPU if you want to CPU encode, of course. So, and bottleneck just doesn't look that obvious there. So, but again, this all talk about bottlenecks, it's like how to build the most balanced system. It's like holy grail. You get slightly more powerful CPU. You end up with a video card being a bottleneck. You get slightly more powerful video card. You end up with a CPU being a bottleneck in the system. So we're talking about gaming. But if you game and stream and record, yeah, that's slightly different. Okay, sorry, I lost one earbud. Not hearing the music. Here we go. So the power's off, right? Right. Let's remove everything. So we are done with testing this motherboard. This was the last test run. We tested this time we tested the new CPU retention bracket. So how are you supposed to get in there and unlock the video card in the slot? Where's my screwdriver? I'm usually doing it with the back of my screwdriver. Or with a wooden stick to avoid damaging anything on the motherboard if the tool for pushing just slips. Here we go. So the VRMs are actually pretty hot. Yeah, this part here. That's the VRM CPU power. Well, not pretty well, yeah, actually. It's not a joke. The temperature of them, it's significant. If we have the radiator that's hot like that, then the VRMs themselves, they're probably cooking. Would have helped having a more kitted out motherboard, because they not usually have more USBs and whatnot and look like cooler. They usually have more CPU power lines. So this one, well, I'm not going to run lean pack all the time here. Yeah, it's going to get some loads, but only occasionally. So organizing some airflow in the VRM air zone here and there, that's definitely a must. some airflow, got to have it there and here. So the radiators, there are radiators, but they are not that big, but they seem to be dissipating actually heat pretty well, because I don't know if you can see it. Let me show it to you. The VRMs are here, down here, but this part's hot. So so this header, motherboard power header, is actually extremely tight on this motherboard, or maybe it's like the plug itself on the cable is a little bit too tight, but it's extremely hard to remove it. Well, this time it wasn't that hard, but it was harder, so maybe it has gotten a little bit loose. Now let's remove the CPU cooler. I just need to find the screwdriver. So let's zoom in on the CPU, on the CPU zone. Just give me a second to adjust it to give you the clear picture right away. This is not clear picture, not clear at all. I understand that. Give me a second. Kinda should go a little bit like that. Yeah. So, and then here. Some zoom here, like this. Like this. Okay, now all the cameras are aimed. And the first thing we should see after we remove this is the thermal compound spread pattern on the CPU's IHS. I'm trying to even unscrew it in an even way. Just a little bit this one, a little bit that one. It's kinda a little bit sad that there's only 2 screws holding it down. I'd prefer to have 4, but technically 4 you can have only with AIO water blocks, or just water blocks. With these gigantic air coolers, there's simply no place for 4 screws in the corners. Okay. What? We are free. And this looks more like it. This looks way more like it. So you can compare these to the picture in my Twitter. Let me actually make a photo This looks like way more even spread. See, there's no pretty much zones with a ton of thermal compound. All the compound is outside. Got just pushed out by the pressure, which is actually pretty good. So even on this level, you can see the difference. Just a second.
Lounge FM Chill Out.
Making a photo. Here we go. AOLOL1, good evening, welcome. Beautiful hands should be a hand model. Yeah, I'm already running to be a hand model. So, okay. Now we have everything we could tested with this new CPU retention, holding, whatever bracket. So, and this is pretty much it for today. So we tested the last untested thing, that this bracket, this frame works properly, and it does. I can see it just by the thermal paste spread. So tomorrow, if something crazy doesn't happen, we will finally start building, rebuilding my main rig using this new motherboard and CPU and memory. So I'll post a photo of the thermal paste on Twitter. Unfortunately, it's a little bit too bright here, so let me figure that out a little bit. So you can see more or less the way it's spread. So it's supposed to pretty much not have pools and lakes of thermal compound anywhere on the HS, the lid of the CPU. So here it is. So thank you very much for watching. Don't leave the stream yet, please. We got to find somebody to raid. Yeah, glad at least this one was successful. The first stream, when I first started this motherboard, was kind of a sweaty one, because the thing of course didn't want to work, and it didn't want to work because it didn't have BIOS supporting certain generation of Intel CPUs. So yeah, amazing, but we had to refresh it without CPU. So please give me a second. Let's find somebody to raid. What's going on my Twitch following page? People playing different games. Oh, I've raided Rob a little bit just a couple days ago. He's playing Control. I'd actually love to try this game. I have Control even. I'd love to try this game, but I have my doubts, and again, I'm a creature of habit, and my habit is like GeoGuessr, DayZ, and whatnot. So let's take a look at what's going on in Science and Technology channel. Any PC building going on? People doing quite some scientific stuff here, but I'm not seeing a lot of live PC builders. Where do they build PC these days? I don't know. Let's just take a look at the tag. Anybody building a PC? Nope. Bear with me. This is a little bit harder to figure out than I expected. Wanted to rate somebody who is doing something interesting. This looks like some really professional soldering stream. They are soldering a big chip with a ton of legs. No, that's a pretty big channel. Okay. I'm not seeing anyone to rate in this section of Twitch. Somebody's doing PCB design. I'm going actually to dive into it. I was going to dive into it, been meaning to dive into it for quite some time, to design some basic, really basic PCBs. So, but ended up getting stuck with this stuff and some other stuff. So okay, since I'm not seeing anybody building anything, let's go and say hello to Mr. Mike Steezy, who is playing some DayZ and sitting at 6666 followers, 666. Sorry, probably there was one more 6. So playing DayZ on official servers, solo, which I only can have a very huge respect for. The way it's meant to be played. See you all tomorrow. Building. Sorry. Going to try to start the PC build, maybe even finish it, but I don't know these days. These days I haven't had this streaming stamina I used to have before, so we'll see how it goes. That's it for tonight. Let's go and say hi to Mike, and I'll see you all tomorrow.